Hi class, this is chapter 1 of our Chem 110 class, so let's get started. So what is chemistry? Chemistry is a branch of physical science. We study the composition, the structure, properties, and change of matter, and all of this has to do with how chemicals, atoms, everything that we deal with, how they behave, their behaviors. So chemicals are a substance that has the same composition and properties wherever it is found. For an example is water. Water is always made up of 2 hydrogens and 1 oxygen molecule, atom. And this is H2O. No matter where it is found in the world, it is always in that same composition, and water has the same properties. If it has 2 hydrogen atoms and an oxygen atom, it is water, and it will have the same properties. So that's what this definition means. Substance that has the same composition and properties wherever it is found. As you can see here, we have a hydrogen, oxygen, and hydrogen. You guys should be very familiar with what water is by now. Atoms and molecules. An atom is the smallest unit of an ordinary matter that forms from a chemical element. Atoms are very small. We cannot see them with the naked eye. Atoms and molecules are tiny particles that compose all common matter. The atoms are bound together to form different type of molecules. Chemical bonds are the attachments that hold atoms together. What does this all mean? First of all, if you have something, and let's say you have a desk, and you start going into layer inside, and you start looking, you will finally get to a single atom. And that atom, so think of like a big mountain, and you're just going down until you get to a single particle. An atom is the smallest unit, meaning that if you break that one atom apart, it is no longer considered an atom. You are now on the inside and you're looking at subatomic particles. An atom is what is considered the last form of a smallest unit of an element, and the element meaning the periodic table. So that's the very last before you break it open, and it's no longer considered the atom. It's of what that element is. For instance, let's say you have an atom of iron. If I break that atom apart, it is no longer considered an atom where you're looking at what's inside of it. It's no longer an iron atom. So that's what I'm trying to say. Molecules are atoms that are joined together. So there's atoms that are by themselves, and there are molecules that are atoms joined, and we'll cover more of that. So if some of these terms don't necessarily make sense yet, they will as you start reading. We're going to look at the scientific method. That's mostly what chapter 1 is about, is how to understand how we look at stuff. So chemists, we use a scientific method. It's a way of learning by we observe, and then we do experiments, and we look at the results. And if the results are not what we thought, then we go back to the drawing board and we do more experiments, and we keep looking. Science is always changing. At one time we thought that this worked, and then it'll change. And it's not that the whatever it is we're looking at has changed. It's how we've looked at it, how we've done experiments changes. That's why one day you might learn that this is safe, and then the next time as you grow older they might come out and say no, it's not safe. It's because we're always constantly looking at stuff, and when we have more knowledge we can change the results based on what more knowledge we have that shows like, hey, no, this isn't right. You know, in the 60s women were allowed to smoke while they were pregnant. Now we know that that's not, you know, it doesn't work. There was problems with that. Things change and adjust with the more knowledge we have, the more experiments that go on. So in scientific method, there's observation, question, which goes with observation, which you would question what you're looking at. An hypothesis results in a conclusion, which is a theory. So here's an example of a picture. Which type of fertilizer works best? So you have plants that are grown with fertilizer A, will grow the fastest. That's what you suspect if you have 3 different types of fertilizer. So you plant the same kind of plant under the same conditions, just with different fertilizer, and you will prove that theory to see if that is exactly what happens. And if it's not, then you might have to reform your thoughts about these observations you made, and you would go back and you would test it again. But everything that you question has to be able to be tested. You can't just make a statement that is, you know, do ghosts wear clothes? We don't know. We can't prove something like that. You have to have something that you can actually put into an experiment. So here's just a breakdown of that. Observation, first step of the method. Observe what is of interest. To question what you observed, you formulate a question around that observation. For instance, the fertilizer. I think fertilizer A would be the best for the plants and they would grow bigger. So let's check that out. I know that's not a question form, but I think you guys understand. Hypothesis, purpose of the experiment. It's an idea that suggests an explanation for the observation. It must be presented in a way that can be tested. Then test the hypothesis through experiments. You create an experiment, has to be fair, has to have some controls so you can have some comparisons. And then a conclusion. A conclusion is developed from the results being analyzed. And if your hypothesis is supported, great, you can do it again to make sure it's reproducible. You can expand on that. And if not, you have to do new testing, you have to repeat the experiment, you have to improve procedure, or you may even have to just discard the thing completely. So this is scientific method. This is what we tend to go through, and it's fluid. Not everything and all these steps work exactly this way, but this is a general protocol for it. So here is some examples. Identify each observation as identify each as an observation, hypothesis, experiment, or conclusion. During an assessment in the emergency room, a nurse writes that the patient has a resting pulse of 30 beats per minute. Now, this is from another chemistry class I have. This is for nursing students, but I also bring this over because these are a little bit more relatable than the science we're going to jump into. So if you can understand some of the foundational stuff in ways that make sense, then you can transfer it over. Okay, so during an assessment in the emergency room, a nurse writes that the patient has a resting pulse of 30 beats. Well, that's not an experiment. That's not a conclusion. That's not a hypothesis. Remember, a hypothesis is you are creating an idea that suggests an explanation to the observation. So this would be an observation. You observe that this patient has a resting pulse of 30 beats. Repeated studies show that lowering sodium in the diet leads to a decrease in blood pressure. I'm just going to jump to these. A nurse thinks that the tan incision from a recent surgery that is red and swollen is infected. So on this one, we would have an observation, which is exactly what I said. Now we jump to the second one, and repeated studies show that lowering sodium in the diet leads to a decrease in pressure. That would be a conclusion, because you found that this happens, but with something else, it created another situation. So this is a conclusion that's been shown in repeated studies that this has been happening. So this is the conclusion of an experiment. They tested this out. And a nurse thinks that an incision from a recent surgery that is red and swollen is infected. That would be an hypothesis. It's not necessarily it could be an observation, but it's a hypothesis because she thinks that because of an observation, something now has happened, and she could easily test this out. So this is a hypothesis about an observation that she made. And that's it. So chapter 1, we are concluded with the matter of molecules and the scientific method.